Welcome back to Bizarre Creatures, fans! Today, we journey into the complex architecture of the coral reef to reveal a small but mighty crustacean that is arguably the most formidable and technologically advanced predator, pound for pound, in the entire deep blue ocean. You must immediately discard any preconceived notions you have about tiny marine life. The mantis shrimp is not merely a creature of the sea, but a master of extreme physics, advanced material science, and biooptics, serving as the reef's undisputed tiny heavyweight champion. The most astonishing and scientifically baffling truth about this animal resides within its two powerful clubs, a pair of raptorial appendages that it keeps carefully cocked and folded, ready to unleash an instantaneous, truly devastating action. Its attack is not a simple strike, it's the culmination of stored potential energy being released to launch a blow so incredibly rapid and overwhelmingly powerful that the underlying mechanics constantly challenge the limits of modern-day fluid dynamics and engineering. The Bow's specialized club is capable of rocketing from a dead stop to a peak velocity exceeding 50 miles per hour in a mere 3 milliseconds, officially cementing its status as one of the fastest and most highly accelerated biological movements ever precisely measured in the animal kingdom. To truly help you grasp the phenomenal velocity and sheer power, the incredible acceleration generated by this small appendage is comparable to a .22 caliber bullet being rapidly fired from a powerful firearm, carrying a startling amount of localized kinetic energy. The hyper-concentrated force delivered by the blow is so intensely enormous and focused that it effortlessly and instantaneously shatters the incredibly thick, resilient shells of crabs, tough mollusks, and clams that would otherwise be completely impenetrable to most other predators. However, the ultimate secret to its lethal effectiveness is not primarily the physical impact of the club, but the secondary destructive phenomenon its speed creates, which is critically known to scientists as supercavitation, as the appendage violently slices through the water at an almost unbelievable velocity. The sudden drop in pressure generates a large, rapidly expanding vapor bubble, which then collapses instantly into a micro-explosion of heated water. The violent, inward collapse of this superspeed vapor bubble does not just fizzle out, it actually produces a second, equally violent, and independently destructive secondary shockwave that slams into the target prey moments after the initial strike. The extraordinary implosion of the cavitation bubble simultaneously generates a minuscule, momentary flash of white-hot light and intense localized heat, a highly transient optical and thermal phenomenon scientifically termed sonoluminescence. This means that, in a single, lightning-fast motion, the mantis shrimp literally strikes its victim not once, but twice. First with the physical blow of the club, and immediately again with a localized, superheated underwater shockwave explosion. The structural integrity and relentless striking power of this creature are so remarkably formidable that specimens kept in specialized research aquariums must be housed exclusively in ultra-thick, reinforced acrylic containers to prevent them from catastrophically shattering the standard glass tank walls. This shocking and seemingly endless physical potential is precisely why its formidable reputation precedes it, often earning it the fearsome nickname Thumb Splitter among cautious divers and seasoned commercial fishermen operating in the coral reefs. Yet, despite the mind-blowing physical strength and weaponization of physics, this is only half of the mantis shrimp's story, as its highly evolved vision system is arguably the most complex and bizarre biological feature found in any organism on Earth. Unlike humans, whose visual systems rely on just 3 types of color-receptive cones, limiting us to the narrow red-green-blue RGB color spectrum, the mantis shrimp's visual superiority is immense. Depending entirely on the specific reef species, mantis shrimps possess an almost unbelievable array of 12 to 16 different, highly specialized types of photoreceptors and dedicated color channels within their compound eyes. This allows them to perceive light in a vastly expanded way, including colors, spectral patterns, and intensities that is so far beyond our sensory capabilities that we fundamentally lack the cognitive framework to even begin to conceptualize or accurately describe. Crucially, they possess the unique ability to see and decode both linear and circular polarized light, as well as near ultraviolet light, which is absolutely vital for complex communication, secret signaling, and tactical hunting within their visually crowded coral reef environments. Furthermore, leading scientific research utilizing their eye structure suggests that the unique mechanism of their light perception could potentially be isolated and adapted for cutting-edge medical applications, such as the non-invasive detection of deep cancer tissues in the human body. Their highly specialized compound eyes are physically mounted on independent, rapidly movable stalks, granting them an unparalleled 360-degree field of vision, coupled with a unique form of sequential trinocular depth perception. Despite possessing this confluence of world-class, overwhelming power, and the most complex visual system known to science, they maintain a relatively humble size, typically growing only to a maximum length of a few inches. These crustaceans are intensely solitary and highly territorial creatures, preferring to live alone within the intricate, meticulously engineered burrows they tirelessly construct within the solid sand or hard limestone substrate of the reef. These meticulously designed burrows function far beyond simple shelter. They are complex, personalized fortresses and hidden strongholds, acting as the mantis shrimp's secure armored sanctuary against the constant threats of the unpredictable outside world. When a significantly larger or more dangerous predator approaches their vicinity, the mantis shrimp immediately utilizes its superior detection and retreats rapidly and safely into its hidden, heavily armored stronghold for guaranteed protection. However, if they are directly cornered, their territorial domain is invaded, or their life is overtly threatened, they will never hesitate to unleash their dual, cannon-like clubs to ferociously defend themselves with the full spectrum of their explosive power. This mantis shrimp population can be broadly divided into two primary predatory strategies: the smasher species, armed with the club, and the spearer species, equipped with a sharp, barbed spear appendage. The smasher is a specialist in lethally targeting hard-shelled organisms, utilizing overwhelming brute physical force instantly followed by the concussive, deadly cavitation bubble shockwave to ensure the prey is rapidly incapacitated. The spearer, on the other hand, is perfectly designed to hunt soft-bodied, fast-moving fish and other agile prey, piercing, impaling, and grabbing them instantly with its sharp, swift, and highly effective harpoon-like appendages. The biomechanical efficiency and structural integrity of their striking appendages are so exceptional that scientists are currently studying their fundamental mechanisms for numerous groundbreaking engineering applications. For instance, researchers at the forefront of material science hope to mimic and apply the club's naturally layered, helicoidal fiber design to create next-generation, incredibly durable and ultra-lightweight body armor for defense personnel. The complex crystalline and laminated structure of the mantis shrimp's striking surface is naturally engineered to resist and absorb thousands of incredibly high-impact blows and extreme material stresses without incurring any catastrophic structural failure. Beyond their physical prowess, mantis shrimps also exhibit surprisingly complex and fascinating social behaviors, which are particularly evident during their intricate, species-specific mating rituals and parental commitments. Intriguingly, a number of these species are known to be strictly monogamous, forming exclusive pair bonds where they mate for life and jointly share and maintain a burrow to diligently raise and protect their vulnerable young over time. In these dedicated pair bonds, both the male and female mantis shrimp will take meticulously calculated turns guarding the precious eggs and developing larvae, representing a truly rare and committed level of shared parental care in the chaotic and dangerous underwater world. Their incredibly vivid, brightly iridescent, and highly mobile colors are not just for display. They are actively used as a complex warning sign and an intricate, rapidly changing communication signal directed toward potential territorial or reproductive rivals. A sudden, aggressive flash of their brilliant, almost psychedelic color palette should be interpreted as a clear message. Stay far away from this zone, or you will immediately face the fastest, most powerful, and most shocking punch in the entire ocean. The mantis shrimp remains a profound biological paradox and a living testament to the astonishing truth that sheer physical size means absolutely nothing when you possess pure, highly specialized, and overwhelmingly shocking biological power and intelligence. Its existence continually challenges and pushes the boundaries of our conventional understanding of classical physics, the limits of biological vision, and the brutal, often unseen, reality of sophisticated underwater warfare and hyperpredation. This tiny champion has redefined power. What other bizarre sea creature with a shocking secret should we cover next? Don't forget to hit that subscribe button for more bizarre creatures.